Hello, it's Mr. Rops here, and today we're going to introduce you to geometric vectors. And what are vectors? So we have vectors and we have scalars. And one of the best examples that I can talk about is if I have a car that is traveling 80 kilometers per hour, this is a magnitude, so this is a scalar quantity. But if I would say I have a car that's going 80 kilometers per hour north, this is the vector because it has both a magnitude and a direction. Okay, and so scalars have just a magnitude, whereas a vector has a magnitude and a direction, and it needs both to be a vector. And we often show vectors, we represent them as arrows. All right, and on this arrow, so like the direction is quite clear, it's going in that direction of the arrow. If it was going north, that would be my direction, and so on. The magnitude is the length of that vector. And so here's the length of this vector. It's going in this direction. We also, on these vectors, we have, this is called the head, and this is the tail. And it means it's starting here and it's going in this direction as the arrow goes. It's fairly straightforward and fairly intuitive as well. If I would have this be a point A and this be a point B, well then this would be vector A, B in that direction. Okay, so it always starts at the tail and goes towards the head in that direction, A, B. So start at A, end at B. But we can also sometimes we show it as lowercase letters, so this might be vector A. And we can do A as a vector with an arrow up top. We can do A as like a half an arrow, or we can do A with a squiggle on the bottom. All those are acceptable notations, but you should note that it is a vector. Oftentimes when we are typing, which I'm not right now, then we make a bold A. So it would be like a bold A is what you'll see it written in textbooks when it's typed. So there's the different notation for us. So vector versus scalar, velocity is the vector, and the scalar is the speed. And I know that another scenario could be some more vector quantities are acceleration and displacement. Force is a vector quantity, momentum is a vector quantity, and so on. So there's lots of vector quantities. All right, so let's do some more basics here. So given vectors A and B, so here I have A and I have vector B. Okay, draw A in a different position. Okay, so what I can do is if here's A, I can take A and move it here. And now I have two different A's. This is also A because it has an equivalent magnitude and it's going in the same direction. So any place I put this is still vector A. It can be anywhere I want it to be. And they are equivalent because the head and the tail are in the same position, they go in the same direction and the same magnitude. Now, if I wanted to draw 2A, well then all I need to do then is take A and add it on here. So now I've made it twice as long, and so now my vector, this is 2A, because it's two of them added together. And this highlights the idea of what is called a scalar multiple. If I look at A and I look at 2A, I can see that they are in the same direction, but just larger. So if I can write A and another vector, let's say B, and if I can just multiply B by some vector to equal to A, then they are scalar multiples. Another way of thinking about it is they are parallel. And so it's referring to the direction only, not the magnitude. And so if I can make this equation up, they are scalar multiples because they're parallel or direction. So scalar multiples is just the vector term basically of parallel and scalar scenarios. All right, so now I'm going to draw negative A. Well, negative A, all I do for negative A is if I take this vector and I rotate it around, so it's in this direction, I just have to make sure that it's, there we go. So this is negative A now, and I'll change the color. I need to change that to red so we know that it's negative A. It's not the same as the green A. Okay, so now base components. on our xy axis, we know we have 1 here, we have 1 here. There is a special vector that goes here, and this vector is called I, because it's going in the x direction, and it has a length of 1. There's another vector here, and that one is called j. Okay, and it is going in the y component. So if I want to refer to the base components, well, I know that from A, I go over 3 units, 3i in the x direction, and I go 2 up in the y direction. So plus 2j in the y direction. So this is equal to vector A in its base components. Similarly, for vector B, I'll switch over to purple. If I'm going to do this, I'm going to go in this direction. Here is negative 2i plus 1j. Okay, and so this is component form of our vector, our base components in terms of I and j. When we go to 3 dimension, there's also a k vector which will go in the z axis. Then it says state them as column vectors. Well, sometimes we can also write them as column vectors. So the x value is first, and this is the 1. Oh, let me write that better. So this is going to be negative 2, 1. It's a column vector. We know it goes x and y in that direction. So similarly, if I'm going to do A, I know I go 3 in the x and 2 in the y. This notation is my preferred because it just makes more sense. This I find busy, but depending upon how the question's asked, you can do either, but if it's asked specifically in terms of these i's and j's, then you have to answer it as such. All right, so one more little extra bit of information here. I know I've done the column vectors. Now, determine A plus B, both as a column vector and geometrically. Well, what this means, A plus B. If I come along here, let me tidy this up a little bit. I know that this is my A vector, and this is my B vector. If I go from A, follow the trail from A to B, and then I take this and put it head to tail, then my A plus B vector is here. I've went A plus B, and so this vector here is A plus B going in this way. I start here, and it's like following a trail. So that's A plus B. To do it by columns, well, if I would take that, let me just erase this for a moment so we can look at it more carefully. If I look at this first one, I'm going to go 3, 2. If I look at the x value, I know on this A plus B vector it's 1. That's the same as taking 3 minus 2. So A plus B is simply going to be 3, 2 plus negative 2, 1. And when I add them, I get 1 and 3 as my vector. And if you look here carefully, x is 1, y is 3. It's in the same as adding the x components and adding the y components to get my column vector. Similarly, if I want to determine A minus 2b, if I want to do that, A minus 2b, well, A is 3, 2, minus 2 times B is minus 2, 1. Looking at the x values of 3 plus 4 is 7. 2 minus 2 is 0. So I get the vector 7, 0. And if I look at geometrically, if I take my A, let's start with A, and I'm going to take B, I have to subtract 2B, which means I'm going in this direction here. Let me make sure it's the right length. Let me take, here's a negative B, it's going in the opposite direction. Copy paste that. I'm going to take it, put it here, put it it here, and we can clearly see that my new vector goes there, and it's 7 units, right? It's 1, 2, 3, 4, 5, 6, 7, which is 7, 0. So I can have do algebra with the components when it's in column form. I can also do it in base form, or I can do it geometrically. And there is your introduction.